Okay, so now we got this system to look at. And again, we want to break this, you want to put it into Wolfram Alpha or whatever. I just say Wolfram Alpha because I think that's the easiest thing to do. But in principle, you want to find the eigenvalues and eigenvectors. How you do that is up to you. I have it in Wolfram Alpha, whatever. The point is that it's important to find the eigenvalues and eigenvectors. Okay, so what are the eigenvalues and eigenvectors? Well, we've got a complex eigenvalue, minus 6 plus 3i, with corresponding eigenvector 1 minus I, 1, and 0. Okay, and then of course there's going to be this one plus the conjugate. Okay, the matrix has real coefficients, so this means that the eigenvalues and eigenvectors are going to come in conjugate pairs. And then we have something interesting. We have an eigenvector 12. The algebraic multiplicity is 2. But the geometric multiplicity is 1. So there's going to be an eigenvector and a generalized eigenvector. 1, 0, 1, 1 is the eigenvector. And then 0, 1/3, 2/3, and 0, that's the generalized eigenvector. Okay. So again, the idea is we want to break this up into two parts. We just want to handle each eigenvalue independently of the other ones. Okay, so the part of the solution that kind of corresponds to the eigenvalue minus 6 plus 3i. Well, remember what we do in that situation. Let me do this in blue. Okay, so the part of the solution corresponding to this, and really this part right here, we break into real and imaginary parts. Minus 6 plus 3i times t times 1 minus I 1, 0. Okay, so what is this equal to? This is e to the minus 6t times cosine 3t plus I sine 3t. And then now the vector, this is 1, 0, 1, 0 plus I times minus 1, 0, 0. Okay, and so the real part is going to be e to the minus 6t times the vector. So for the real part, we'll have cosine 3t plus sine 3t, sine 3t, cosine 3t, 0 plus I times e to the minus 6t, and the imaginary part then is going to be given by so the vector will be minus cosine 3t plus sine 3t. Then the next one will be minus cosine 3t. And then the next one will be sine 3t. Okay, so that's the real, and that's how we broke the vector into real and imaginary parts. Sorry, I'm gonna need to make that smaller. Okay, and we know what to do when there's a repeated eigenvector. And so this tells us that the general solution, I'm gonna have to write really skinny vectors, is going to be a times the real part, a times the real part of this plus b times the imaginary part. So that's going to be a times e to the minus 6t times cosine 3t plus sine 3t, sine 3t, cosine 3t, 0, plus b times e to the minus 6t, and this is going to be minus cosine 3t plus sine 3t minus cosine 3t sine 3t, 0. Sorry, I forgot the 0 here. Okay, and now we're going to add the part that corresponds to this part with the generalized eigenvector. So this is going to be a tight fit plus c times e to the 12t 1, 0, 1, 1 plus de to the 12t t times the eigenvector 1, 0, 1, 1 plus the generalized eigenvector 0, 1/3, 2/3, 0. And I just realized I wrote it down wrong up here. This is 1/3. So let me rewrite that. This is 1/3 and this is 2/3. Okay, and now I just realized probably everything that I just wrote is off the screen, so I'm going to just come up here and try to write the answer a little bit bigger right here. But I'm gonna have to scroll back and forth, so hold on a second. All right, so this is equal to, but I can ae to the minus 6t times the real part, which is cosine 3t plus sine 3t, sine 3t, cosine 3t, 0, plus be to the minus 6t times minus cosine 3t plus sine 3t minus cosine 3t sine 3t 0 plus c. Okay, this part is going to be the generalized eigenvector part, e to the 12t 1, 0, 1, 1 plus de to the 12t t times 1, 0, 1, 1 plus 0, 1/3, 2/3, 0. And that's it.